Hi, in this video here, we're going to do an introduction on how to sketch cosine function. And the cosine function that we're going to refer here is referred to the form of, I have cos, brackets here, the angle, come with linear expressions. And the rest of the parts, we have constant. And to have a better idea on this form here, let's refer to the example function I have below. For example, I have fx equals to cos x. If I want to compare corresponding to the general functions on top here, so I will have the capital A, which is the coefficient for the cos is positive 1. Coefficient of the x, m, is positive 1. The constant c and k is 0. The next example, cos 2x now, it will just happens to be compared to the previous one. The changes is on the coefficient of the x, which is the m value changed to 2. C and k is still 0. Coefficient of sine cos is still positive 1. For the third cases, we have extra terms compared to the previous one, where we have minus pi over 4, where this minus pi over 4 will corresponding to the constant c. And then for the fourth one, negative cos x, if compared with the first one, the difference is on the coefficients on the functions, which is the a value here. For plus, turn to be minus. And the last cases, we can see all the a, m, c, k with a corresponding value, where the a, the coefficients of the function is 3, positive 3. Then the m, coefficient of x, negative 2. Constant c, the constant inside the bracket, pi over 3. Constant k, the constant outside the brackets, 1. Go on. And beside this form here, there is also some things that we need to take notes, which is similar like the case of sine. Cos also we have amplitude, and how we get the answer for the amplitude is that we take these coefficients on cos, we modulus it, that will be the answer. And what is amplitude? If let's say this is the shape of cos that we have, the length of this dotted line point until this part of the graph is the amplitude, so do the other side. If you notice, actually both sine and cos, they are actually having the same shape of graph, which is the sinusoidal graph. So that is how we can see. Next, the cycle of the cos function here, I will make it considered begin with mx plus c equals 0 later to do graph sketching. And in general, the domain of cos function is infinity to infinity. It can take any x value. Whereas for the case of range, it will having the constant k here plus minus with the amplitude. And of course, this general domain and range is meant for cos function in this form here, not some other form. Next, let's see some important terms that we need to take notes in order for us to do graph sketching later. First, we need to know what is the phase shift, where the phase shift is referred to with taking the mx plus c from the functions there, make it equal 0, and this is all us to find the initial point of the cycle. And what I mean by initial point of the cycle, let's see. If let's say I consider the case 1 graph like this for cos, case 2 graph like this for cos, for both of these cases here, the initial point will be the point that I have now plotted in red. So whether it's a case 1 graph or case 2 graph, it depends later when the time we done our construction of table and start the plotting. The next important terms that we want to go through here is the period. Similar like what we have in the case of sine, where the period is calculated by having 2 pi divided by modulus m, where the m here is come from the coefficient of x, and this is to determine the length of one cycle of our cos graph later. So how's the one cycle cos graph looks like? It may look like case 1 here or case 2. Depends what we have for the result in our table later. So the length will be like what is illustrated by these 2 red arrow here, which is the periods. Next, the next term important to take note is what we call as the subinterval width. Again, is similar like the case of sine, where we calculate by using having period divided into 4 parts. to determine the common difference of x value that we're going to use in table for graph sketching later. So to illustrate the subinterval for case 1 and case 2, it will be as follow. So these are the subinterval in our graph later. Then next, I would like to refer to the next term here is that we go for the table. So in the table, we will construct two columns table with labeling as x and fx, where the x term will begin with the phase shift value that we have just now, and then followed by the 4 consecutive x value with the common difference of the periods divided by 4. Then we find the corresponding functions value. And lastly, we go for the graph, and we're going to sketch the graph begin with one cycle graph based on the table. Then we extend or reduce the graph according to the domains. And this is a rough idea on how we have our graph of cost done. And to have better idea, we will see in example later.